It's Timo Kelde who will present the Unseen Open project, which is a reproducible workflow for a seasonal forecasting data. So Timo, the floor is yours.
Thanks, Julia. Yeah, thanks for making this project available through ESoC and for hosting this event. So yeah, like you introduced, I'm sharing, I'm aware of the time, so I'll try to keep it short and general, but yeah, I'll illustrate what we're doing in this project. So instead of machine learning like we've seen in the previous presentations, here we're looking at creating a workflow to assess extremes beyond the observed record. And let me explain to you first what I mean by this. So Unseen is an acronym that stands for the Unprecedented Simulated Extreme Ensemble. And the idea of this method is that you can simulate many extreme events that could have occurred but haven't been recorded yet. So therefore, by simulating many extremes, you can better assess what kind of extremes could occur in our present climate. So as illustrated here by the Met Office, you can create many virtual observations and therefore have a larger sample of extreme events that can occur compared to real observations. And the use of this method is that you have a larger sample of extreme events, and therefore you can understand the risk better of extreme events. And through that, you can build climate resilience or, for example, enhance global food security. So this method requires you to handle a lot of data, and thorough evaluation is necessary to evaluate your extreme events that you're simulating. So therefore, we are working on this Unseen Open workflow where you download, evaluate, and illustrate the method. So this can be better taken up by end users. Yeah, the workflow is illustrated here. Everything is in Jupyter, but we do use both Python and R languages. And we've had some discussions about this, but we think Python, XArray, and especially lazy loading of data through Dask is best for data handling and downloading, and extreme value statistics in R is used in the second and third steps of the workflow. Yeah, and if someone has any ideas or thoughts on the workflow or anything else that I present, please ask through Slido or send an email. Happy to get in touch. So I'll quickly take you through a case study that we perform with this workflow, the UK February precipitation. So last February, there was a lot of rainfall over the UK, which caused severe damage. And here in the workflow under downloads, we try to generate this unseen ensemble from the climate data store, the CS5 dataset in particular. Then we evaluate this data, how robust is the ensemble, can we use it? And then we illustrate the use of this. So the research question is, with what frequency of occurrence can the extreme event that we have faced be expected to occur, given this large sample of the unseen dataset? So then download first, a short introduction to CS5. This is the seasonal prediction system of ECMWF. And to calibrate the system, they run the model since 1981 to 2016. They initialize many forecasts. And they initialize it every month. So the graph that's illustrating here shows that the forecasts are initialized every month, that you can pool those months together because they're all forecasting February and they all have multiple ensemble members. So in total, you have 125 forecasts forecasting each February over those years, which means you multiply your observed record by 125 times. So I illustrate that here on the left in the evaluation step, the time series. So the blue crosses is what we know from the observed record that occurred over the UK. So for each year, we have an observed precipitation average for February. But then within CS5, within this unseen ensemble, we have 125 forecasts of what could have occurred. And therefore, in this ensemble, you can find more extremes and find more of the tail of the distribution. Then on the right, so from the time series, you would say that the CS5 and EOPS seem similar by eye, but then we propose a fidelity test on the right. I'm not going to go into details here, but that shows that actually there's too little standard deviation, so too little variability within CS5. So again, if someone has an idea why this might be caused by CS5 or wants to know more about the fidelity test, please get in touch. Illustrating the use. So these is a traditional way to estimate extreme values. So this is an extreme value plot where you on the x-axis show the return period. So this is how often you expect an extreme to occur. So for example, and then on the y-axis the event magnitude. So February average precipitation in this case. And the blue dots are the observed events. So for example, the highest blue dot is the highest event on record that you would expect to occur around once in 100 years within this record of 100 years. And then within the model, within the unseen simulation, CS5, you have many more extremes. So therefore you would theoretically be able to estimate what is happening once in 1,000 years. However, this plot also shows the problem here that the black dots do not capture the blue dots, so they do not follow the system because there's too little variability. And therefore it highlights also this importance of evaluation. If you would just use this without thorough evaluation, that could be problematic. And next up, we're thinking of redoing this workflow for Siberian heat wave that we're facing now. So it would be really interesting to see whether CS5 in this unseen method can simulate events such as the 2020 event, and then how does this large sample of events compare to the one we're facing now. And in terms of the workflow, this is interesting to test the transferability of our downloading approach, because we're using different variables, space and time scales. And it will be interesting to see whether our evaluation methods are robust as well. Do we encounter other problems? So that's what we're going to work on in the coming months. So then wrap it up with the documentation. Yeah, check out the Jupyter notebooks, GitHub, and in case of any questions, please ask. That's the presentation.
Thank you, Timo.